Imagine traveling back in time 40,000 years ago. The world is a wild, free place, home to creatures we can only dream about. But you wouldn't be alone. Meet the Neanderthals, our ancient cousins. Now you might think they disappeared without a trace, but hold on. They left something behind, inside us. In 2010, scientists made a groundbreaking discovery. They sequenced the Neanderthal genome. What they found was astonishing. We, modern humans, share about 1–2% of our DNA with Neanderthals. That means Neanderthals are not just distant relatives, but part of our family tree. When they analyzed the genomes of people across the globe, they found bit of Neanderthal DNA. These snippets vary from person to person but are present in all non-African populations, indicating interbreeding occurred after humans migrated out of Africa. So what does this Neanderthal DNA do? First up, skin and hair. Neanderthals had spent millennia at higher latitudes with less direct sun exposure. This reduced sunlight meant less natural vitamin D production. According to John Capra, an evolutionary geneticist at Vanderbilt University, changes to hair and skin biology helped Neanderthals and eventually modern humans adapt. These changes allowed them to capitalize on lower sunlight levels while still producing enough vitamin D to stay healthy. So if you have freckles or red hair, you might owe that to your Neanderthal ancestry. Next, the immune system. Neanderthals had to battle numerous pathogens, and they developed robust immune responses. Some of these genes were passed down to us, helping modern humans resist infections. However, there's a twist. These same genes might make us more susceptible to allergies. Our metabolism also got a boost from Neanderthal DNA. Genes related to fat storage and metabolism helped Neanderthals survive periods of scarcity. These genes are still with us, affecting how we process fats and carbohydrates. In today's world, this might contribute to higher rates of obesity and diabetes. Even our behavior has been shaped by Neanderthal DNA. Studies suggest these genes could influence mood disorders and addictive behaviors. It's a mixed bag. While some traits might have been advantageous in prehistoric times, they pose challenges in our modern world. But the story doesn't end there. Neanderthal DNA contributes to the incredible diversity of the human experience. According to evolutionary geneticist Rasmus Nielsen, one of the cool things about interbreeding is that it essentially fast-tracked evolution. Instead of waiting for beneficial mutations to slowly arise, interbreeding introduced a ton of genetic variation at once. This rapid influx of new genes allowed humans to adapt quickly to new environments. So how long will these traces of long-lost humans linger in our genomes? Over hundreds of thousands of years, some Neanderthal fragments will gradually be eliminated from our DNA. Others, however, will become firmly embedded, says geneticist Joshua Akey. This means that while some Neanderthal genes may fade away, others will remain a permanent part of our genetic heritage. And there you have it. The incredible tale of how Neanderthals live on within us. Science is not just about the past. It's a story that continues to unfold, connecting every one of us in ways we've never imagined. Thank you for joining us on this fascinating journey through time.